Okay, we have to find the area of a pentagon with an apothem that's 5 units long. So an apothem is the height of a triangle when you divide the pentagon into smaller triangles. So if we take this purple pentagon and divide it into 5 equal triangles, then the apothem is this right here. It's the height of this triangle. Okay, now how are we going to find the area? Well, we need more information. Well, we're given everything. First, I'm assuming I'm finding the area of a regular pentagon. So it has to be regular. And it does say that in the directions, but I cut that part off. So regular pentagons have all equal sides. So all of these sides are equal to each other. And all of these are radiuses. So they're equal to each other. It's called a radius because if you inscribe this pentagon in a circle, those would all be the radius of the circles. So we got 5 congruent triangles. So if we could find the area of just like one of these, multiply it by 5, then we're good. So since all these triangles are congruent to each other, all 5 of these angles are congruent to each other by CPCTC. And they make a full circle, so they add up to 360, which means that each of those angles is going to be 72 degrees. Okay, which means that when you split this angle in two, it's going to create two 36-degree angles. So we have the height of this triangle, we just need to find the base. Do base times height divided by 2. So to find that, we're going to do SOHCAHTOA. So we're going to use tangent because we're looking for that opposite leg of 36 degrees, which I wrote as x, and we're given the adjacent leg. So the tangent of 36 is equal to x over 5. Alright, when I cross multiply, I get x is equal to the tangent of 36 times 5. So if I type that in my calculator, the tangent of 36, and then multiply it by 5, I get 3.63. Which means that if I double it, this whole side length here is going to be 7.265. So we'll just round it up to 7.3. Alright, so now I have a triangle where the base is 7.3 and the height is 5. And if I find the area of that triangle, all I have to do is multiply it by 5 to find the area of the whole pentagon. So I'm going to do 7.3 times 5 divided by 2 to get the area of one of those triangles, and then multiply it by 5. So I get, as a final answer, for the area of the pentagon, comes out to be 90.8 square units. Alright, and yep, 7.3 times 5, that should work. Yep, 90.8 square units.